Yeah, literally, the last 50
Alright.
years you've had.
Definition. Factory. This is like actually kind of key. Factory. Making things simple. Simpler. Smaller bracket. Now I know that is not the technical definition, and I probably have a spelling mistake in there. That's okay. I'm sure Mr. Harum did a lot more like formal definitions with you guys and everything like that.
It's things, not thing.
And I know, like I felt bad about that. I knew I probably should have prepared you guys better for that, but I didn't. So hopefully, I'm sure you guys figured it out along the way.
Oh, you would give us definitions, but I never really yeah. Yeah. It's just,
Math's hard enough, I think. So let's make it as easy as we can. So we're going to be breaking things down, okay? We'll do trinomials and some binomials and some common factor stuff today, and then we'll talk about the differences between rationals and radical numbers. No, rationals and real coefficients. Okay, so slipped out. That part will get a little weird, but don't worry about that too much. And then tomorrow or Monday we'll get into cubics and stuff like that. So let's start with difference of squares. Now I know I've taught you this one because this is one of my faves. So it's when you have two things that are squared being subtracted from each other. You can break down into two brackets, right? One is positive, one has a negative. Because if you do the distribution or FOIL to this, you're going to get these two numbers here back. So, for example, 9x squared minus 25. We can take the squares of all these guys. Everything's a perfect square, so it works out quite nice. We'll come back to that in a minute. Okay, kind of looks familiar, right? All right, next one was a trinomial. Oh, no. Once we have something like this. Our good friend, the quadratics. There's lots of this stuff. This is pretty much a pre-calc 20. If you break them down into some kind of bracket, where R and S are your factors or your x-intercepts, right? Now remember, R and S, when you multiply them, will give you C, And when you add them up, it gives you P, right?
Wait, what does RS stand for?
They're just the term, like whatever you come up with. I'm just using lots of letters right now. These are formal definitions. Okay. So, for example, something like this. Yeah.
Or you could use that one too.
Yeah, or 6 and 1, right?
Oh, I know. That's what I was thinking.
No, you can't use 6 and 1.
Okay.
Because if I use 6 and 1, it multiplies to 6, but 6 take away 1 gives me 5. When I multiply them, does that give me -6 or +6? No, so you can't use that one. That one gets me all the time too. Stuff like that. Now, did I need a calculator for that?
Yes.
No. Still don't need a calculator. We're still okay. Okay. What's that?
I think you need a calculator.
Now, sometimes when you're factoring stuff, you can't break it down quite nicely. So then you have to use this guy. Our good friend, the quadratic equation.
That's going to be your best nightmare.
We don't use this a whole lot actually in calculus. Most things do factor down quite nicely. Remember when we did last year rationals, where you did like fractions in algebra? The brackets always kind of worked out quite nicely, and you could cancel stuff out. You'll have a lot more of that here. Okay. This is typically the hardest part of calculus. It's because they factor and simplify everything down to the nth degree that people have a tough time finding all the factors. Okay. So. Then, of course, sometimes the trinomials, they get a little trickier. Now, I'm not smart enough to make up these ones. So, I will. Borrow the change. Hard to use. No. So. You changed my book?
Oh yeah, I took out all those coils,
Did you play around with it?
flipped the pages around, and then put the coils all back in.
Huh.
Just to throw you off a little bit.
Sorry, I found it. All right, something like this.
These are still trinomials.
These are trinomials. 1, 2, 3 terms. Still quadratic. Now, Kira, did you learn decomposition as well?
Yeah,
Do you like it?
yeah, we use that more than guess and check.
Really?
Yeah.
I'm still going to guess and check. That's what I like.
Drag.
You can decomp. You understand. You know the steps.
Yeah.
I don't need to show it. That's good because I haven't done it in like 10 years. So I'm not going to start. How are you guys with guessing and checking?
Good.
Still, like, it's not the favorite thing in the world.
Do you like decomposition?
I don't know.
Or do you guess
I'm
and
just
check?
bad at it. Like I can't. I never.
wanna
like,
learn
I never get it.
decomposition.
So I assumed if there's like a set of steps that I can follow to get it, why would I do it? You know?
Yeah,
Like
so-
if I can't, like it takes me like 10 years. to
Yeah, because if we can, it takes forever. Like my last exam, it took me
Well,
10
like
minutes.
decomposition,
Like if I can't use a calculator, especially. I'll
like
be
if you
like-
decomp, from what I remember, you go this times that, right?
Why are you looking at me?
Well, because Mr. Harum showed you guys this, right?
No.
I didn't know.
No.
That's 90, right? So now you look for factors of 90 that give you 1. That would be probably 9 times 10, right? So it should be -10 and +9. And you got to lump the factors together. So I know like 10 and 15 would work, 9 and 6 would work. Because you could take a 3 out of the 9 and the 6 and a 5 out of So,
I'm so confused right now.
right? Does that make sense?
Yeah.
If I add these two together, I still get the middle term.
Okay.
And then you take a common factor out of these ones, and you take a common factor out of these guys. I can take a 5x out of all this. And I can take a 3 out of this one.
Oh yeah. Sure.
You could, I don't know. I would like you guys to, oh, it's right here. Erase this off from your brains afterwards.
I'm okay.
You're okay. If you want to decomp, follow this.
Is that your phone?
Blow it up.
Is that your
Mr.
phone?
Weber has contact release.
It's probably from my mom.
Did you eat your sandwich this morning?
He's gonna love this.
Lunch? How was your sandwich? Did you get my little note?
My first job in Elrose, the gym teacher, he was bad for having his phone out and texting during class. And every time it would go off, he'd be like teaching and go like ding, and he'd be like, oh, it's babes. And he'd walk over. Wildly inappropriate stuff.
I really like how you.
It's babes.
I really like how you recorded.
Oh, oh, now it's gonna be on YouTube.
That's gonna be my new ringtone. My new ringtone. Oh, it's babes.
Oh, babes.
You know how funny that's gonna be? I'm just gonna get someone to call me in the middle of class just for
Please
the
don't
fun.
tell your mom I told you that.
It's
Okay,
gonna be on YouTube.
now we look here.
So letting me.
These two are the same, so we can now like technically take out a common factor of 3x minus 2, and then all I'm left with is 5x plus 3. Because technically, if you were, yes.
What? That's crazy. I don't
Okay.
know why that's so shocking to me.
The hard part I find with this is that you got to find the right one here, and you got to put it in the right order.
Oh.
It's
yeah.
kind of the same thing actually with guess and check. I guess they're both kind of have their drawbacks.
Yeah.
I just find like with this, you'll find it eventually, yeah. But there's a lot of steps here. Whereas I find with guess and check, once you get used to it, and if you practice it enough, it just gets easier.
You've never
And it-
used decomposition.
Well, like I would never think. Well, I don't know.
So on an exam, are you gonna have like do decomposition, or is it gonna say?
No. How this shakes down is we're going to have a review test on this stuff, and then you just use it for the rest of the course. Like, I'm not testing you on this stuff ever again. This is just review stuff.
Yeah.
This is just to make sure you're up to speed and ready to go for calculus.
So was I ever taught proper decomposition then?
I never taught you.
Then I never learned decomposition.
I think you guys said Mr. Heron tried showing you guys?
Not really, but
down. I don't know if he paid attention.
He was a fan of it. I know he tried teaching last year's grade 12s when he taught them in grade 10. And then I showed them guess and check, and they liked it way better, so.
guessing and checking just literally as long as you get the right answer, you can't mess up.
No, you can't. Let's see if I can find another one here.
I feel bad for the kid who just watched this video. She's gonna have to watch 14
I'm gonna
minutes.
take a picture of that. So I don't know if it changes this.
If she has to watch 14 minutes of this, how much do she actually will get? Like 7.
So, she can watch it at high speed too. Let's try another one. This
Boom.
one, though, I'll do this one with guess and check though. Just to show the difference between the two.
Yeah, what was the final answer? Can you go off?
Oh, sorry, yeah. So my final answer is this guy here.
3x minus 2. Oh, babes!
Shouldn't have said it.
If it's the time to go to 12.
Yeah.
Oh my god. Would that be?
Yes. Okay. All right. So with this one, you got to find factors of this guy and work with factors of this one. And kind of play around with it.
5 and 2 and 6 and 2. That's not gonna even be close.
I'm going to go with 12 is going to be 4 times 3. And x squared is always x times x. And I'm going to try 10 as 5 and 2. Yeah. No, that's not going to work.
Wait, did they just add inside and
Oh, wrong way.
what's it?
Wrong way. So now what you do is I'm going to show you guys what it looks like when you do it wrong, and then I'll go back and switch things around. So you multiply the inside numbers, 6x. Multiply the outside numbers, 28. Can I add that up in any way to 23?
No.
No, so it's wrong. So I'm going to go 5 and 2 now. Sorry about it if you're writing this all down.
No.
It's not in pen, is it?
No.
15 and 8 words.
15. 8. Yeah. So it has to be negative 23, so both of these have to be negative numbers. And then it's done.
Has to add to make it.
Right. That's how you do your check. So it's up to you to use whatever method you like better. I'm not going to discriminate, even though I prefer this method. So it's up to you guys, whatever you choose. Okay, any questions about that? Still kind of okay with this? Okay. All right, I think the last thing I want to do today is the most important part, so hopefully Mac watches minute 17 and on. Is I want to talk about factoring over reals and over rationals. Okay. Reals? Yeah. Real numbers. Okay, so we use symbols for this stuff too. Now rationals, the symbol for a rational number, or sorry, for a real number. Nope, I got it backwards, sorry. The symbol that we use for rational numbers is we use a letter Q. Okay. And for the reals, you guys have seen this before. You guys remember the symbol for real numbers?
R.
R! R!
Fancy R.
Fancy R! I don't, of course I have it.
Yeah.
Yeah. Okay. So if you're asked to factor something over a real number or a rational, it makes a difference. Okay? How do I want to explain this to you guys?
Goodly.
Goodly.
Oh man, looks like an octopus.
Okay. So when we're talking about rational numbers, these are whole numbers and fractions. Okay, think of it like that.
That's for rational.
Yeah.
Whole numbers plus.
And fractions. Okay, that's what I'm talking about there. So anything like a 2, a -5, -1/2, stuff like that. With the reals, it gets a little different. We can use things like radical symbols and other numbers as well. Okay. So here we can use just about anything. But mostly we'll use radicals. So we break it down now. Factoring over rationals, much easier. Factoring over the reals, a little interesting. Okay. So now if I was to ask you guys, back to the following. Over real numbers. Some examples of what that looks like. Start with an easy one. Although I want to factor x squared minus 7. Now, 7 is not a perfect square, is it? But when we can start to use radicals with our reals, now it gets interesting. X and x for x squared, right? Now the square root of 7. Square root 7. Square root 7.
No, they did.
I just dropped a huge bomb.
And they ruined your moment.
Yeah. It's all right. Did you get what I did, Kira? I took the square root of 7. And just put it there. Do I know what the square root of 7 is? No.
Like,
But I can put it as a radical. Okay, so I just put rho as a radical. So radical 7 times radical 7 is still 7. Right?
Wait, sorry, can you explain that one more time?
no,
I was just distracted.
I shouldn't, hey?
My aunt texted
play them on the phones.
Yeah, right? On their phones.
That's all I'm walking now.
You should hear this text.
Sending
Yeah,
snaps.
I'll read the text.
It was
okay?
my aunt asking me what time it was.
It says, did you know that your car Nene is the name of an endangered goose in Hawaii? Like, I
The more you
can't,
know.
I can't just ignore that.
I like how no, that's on the video too.
Yeah, no.
Yeah.
This is just gonna be like the wildest.
Matt's like pulling her hair out. Oh, gosh.
Yeah, she'll find it.
Oh, okay, she will actually. That's true. Okay, so yes, difference of squares. You take the square root of both numbers. So x squared is x. Square root of 7 is root 7, root 7. And that's what you do with real numbers when you're factoring over real numbers. Okay. Another one. Let's do another example.
Wait, so my question is,
Yeah.
is when you put those back together, when you put root 7 and root 7 back together, do they equal 7?
Root 7 times root 7.
Yes.
What's 7 times 7?
49.
What's square root of 49?
7.
Not 7.
Not 7.
But shouldn't you?
Don't
Shouldn't
overthink
you
it.
have 2 square roots?
Now you're just trying to make something to stumble me here. But
7
you,
times 7 is 49.
Yeah.
Square root of 49.
Okay.
If you want to be like that, then I guess you're right.
I am.
I was confused. I was confused, and you answered my question.
Okay. Let's go 3x squared minus 12.
Is there gonna be like the cashbacks, like 50% cashbacks on the test?
I can't remember now.
Because that's the ones I'm having trouble with.
Oh, so like if you get like 3% cash back times your purchase
You should really have a clicker.
by
to pause.
0.0.
Yeah.
Okay, so for this one here, um, it's gross. Okay, x squared is still x, right? I don't know the square root of 3. So it's x root 3.
You don't know the square root of 3. What?
Root 12.
There's no.
Plus root 12. Now, I can simplify root 12 actually.
Mm-hmm.
12 is 4 times 3, right? Square root of 4 is 2.
Isn't the plus real one? Yeah, this is so that's what it is.
Yeah.
How did you get it? X.
I know the square root of x squared. It's just x.
Okay. Oh, and then
I don't know the square root of 3, so it stays root 3. 12 is 4 times 3. Whenever you look for factors, you know the square root of. So 6 times 2 doesn't help me here.
So why is it root 12? I don't understand.
Because you take the square root of it, right?
But why? There's no square root up there before.
No, but when you're factoring a difference of squares,
Oh.
you take the square root. That's the rule.
Solely.
Yeah. I should show you a trinomial one. Now, what's nice is, like, if I asked you to factor the same one here, like this is over the this is over the rationals, right? So this is the reals, right? Now, if I asked you to do it over the rationals, I'll stick with this one here. If I wanted to factor this over the rationals, we can't do anything to it. It just stays like that. If you can't break the numbers down perfectly into nice numbers, leave it alone. It's done. Okay? Okay, I want to find a... Maybe I'll leave it there for today.
Sounds like fun.
Oh, I know. Like sometimes it's going to ask you, you have to do it for a trinomial, like let's say, yeah. Well, that should be 2x. 2x minus 4. Now let's say we want to factor this one over the reals. Sorry, I'm going to get rationals and reals mixed up sometime sooner or later, so really trying here.
Make it later.
Reals.
Make it when I'm not here.
Okay, so for the reals, that means we can use radicals, right? So what we'll do for that, whenever you got to factor a trinomial over the reals, use the quadratic equation, because you can use radicals. Okay? You could try to factor this one. If you can still do it through decomposition, or guess and check, try.
we don't have a calculator for this stuff, right? So we're just all
Right. These are easy numbers to work with, though.
Yes, very.
I know I probably sound like a huge jerk when you're like, I need my calculator. I'm like, this is easy. Don't worry about it, Bella. And you're like, yeah,
I do math in my head.
so easy. Thanks. It's easy for me to say that. I understand. I forget that sometimes.
Yes.
I totally understand that I come off as being a bit of a jerk sometimes. I'm like, easy.
No, no,
It's easy.
good. I just think I should get better at mental math.
Exactly, and that's what I'm trying to get you guys to do.
Exactly.
Yes, you're terrible at it. I'm trying to help. No.
No, just do it.
Okay, won't work.
Intervention.
Just have to do it.
So we got to use the quadratic equation. Okay.
Well, dude, I just wrote all that down.
Well, it's okay. Put an X through it. It's fine. That's the notes.
Drink.
Drag. Okay, so let's use the quadratic equation. So negative b, so it's already negative 2, so it stays positive 2 now, plus or minus square root b squared minus 4ac divided by 2. Okay. I hope I got that right. I always have a weird thing now about getting that wrong. Remember when we did those like learner posters up there? It was your sister that noticed I put the quadratic equation down wrong on my poster as a math teacher. So now I'm like super paranoid. So if we work this out, so let's do some mental math in steps.
6 is on the bottom.
Very good.
I'm a wizard like that. And 4.
Yeah, I figured you would be okay actually with the with no calculators.
Me?
Yeah. So, 4 times 4 is 16, positive 16, times 3,
32 and 16 is 48. Oh, no, you have to times it.
48.
I was right. Oh, yeah, because just through 16.
Yeah.
48.
It's okay, it's okay. So it's positive 16 because there's 2 negatives. So positive 48 plus 4.
Minus 4.
No, it's positive. No.
What?
Yeah, when you square
Yeah.
negative, it's positive.
Yeah, positive. Oh yeah, positive 4
Minus.
plus 58 or 48.
Why is it plus?
2 negatives.
Oh, okay.
Okay. Not so bad. We're doing okay. No calculators. 52 would be 4 times
I can't help you that one.
Yeah. Like,
4 times 13.
How are we supposed to know that?
Guess check.
but
Like I said, for the first bit, you guys are still allowed to use a calculator.
Wait, don't you have to
I'm
divide
weaning you guys off. We're not going cold turkey right away.
Don't you have to divide by 6?
cold turkey.
Yeah. Okay, so I can take a 2 out of everything. And then I can take a 2 out of all this, out of all 3 numbers.
Wait, go back up.
No, let me finish.
Oh,
You lost. My compass. I haven't used that one in years.
Years, you make yourself sound so old. Like you're
Feel
just this like old man that's lived through everything.
I have. Like, I've seen it all.
So why?
Except for the bear catching the fish in the river.
Yeah, then once I see that, game over.
Wait,
What?
so you took a 2 out.
Yeah. Took square root of 4, it's 2.
Why did you take the square root of 13?
You can't.
What's square root of 13?
You took the square root of 3. Square root of 13. Oh,
I took 2 out of all these.
okay.
So these are my roots. Okay. So that's how you would do this. And then technically how you would write it, yeah, would be like this. So these are my 2 x-intercepts, right? One is 1 plus, root of 3, and the other one is 1 minus 18 over 3. So if you wanted to factor, what you would write it as, you just write x minus 1. Yeah, because they're both positive. And x minus. Like that. Because you know when you take it out of the bracket, you change the sign. Technically, they're both positive here. So when you put them back into the bracket. Yeah? And it's just like, yeah, okay. All right, so that's half of 1.2. We'll stop there. What? All right. So. On page 64, or 16, sorry.
Just jump in.
3, 4, 7. Eight. No. All right, we'll go there. 3, 4, 7, and 8. And then we'll get into like cubes and what do you do when there's a fraction, when x is to the power of a fraction. On Monday. Great way to start the work week.
Can I remember? Oh, you're still.
That's okay.